So what's momentum? It's basically a property of moving objects. So anything that has mass and has velocity is going to have momentum. So the only time an object has no momentum is when it's at rest. And basically, it's very easy to calculate. Basically, momentum, we represent it as a small p, little tiny p, lowercase p, and it's just equal to the mass of the object times by its velocity. And then it just uses those units. So mass would be kilograms, velocity would be meters per second. So the units for momentum are kilogram meter per seconds. It's written there anyway. So kg m s to the minus 1. So momentum is a vector because if you remember, we were talking about in class how if you multiply a scalar by a vector, you get a vector. Well, that's what we're doing here. So we've got mass, which is a scalar, and we've got velocity, which is a vector. So momentum is a vector. It has direction. So I've got an example here of how you use your P equals mv equation. Basically, we've got a ball rolling along. It's a 5 kilo ball, so that's its mass. It's traveling at 14 meters per second to the right. We put our data down because every time we don't put our data down at the right, a physics fairy dies. Okay, so you've got to make sure you put the data down and save those physics fairies. So we've got our data, we've got our equation, and then we've just substituted in, and we end up with our answer in kilogram meters per seconds. And we have a direction because it's a vector. So I've given you 2 little questions here just so you can reinforce that and have a think about how to use the equation. Have a go at those 2 before you go to the next slide, and I've given you the answers right down the bottom too. So have fun with it. Bye.